to multiple two-dimensional images. Okay, so this is the syllabus, and before I start, so here you can see that types of views. Okay, so in types of views we have parallel, and in that we have orthogonal and oblique. Okay, so in that again orthogonal is divided into multi-view and axonometric. So in axonometric there are two types of axonometric, in the sense it is a three-dimensional view. So here one is oblique view and another one is axonometric. In another words, it is also called as isometric. And multi-view drawing, this multi-view drawing only we are calling it as orthographic drawing or orthographic projection. Okay, and comparison. So this particular uh, image talks about what are the advantages or between one projection and another projection, or one drawing to the another drawing. Okay, so here you can see that multi-view drawing, just now I mentioned that multi-view drawing is nothing but orthographic projection, accurately presents objects details, that is size and shape. So in orthographic view, so if I say that the image dimension is 100 mm, in orthographic views in any of these like front, top and side, you will get the dimension as exactly 100. So requires training to visualize. So that is the drawback of multi-view drawing. And coming to pictorial drawing, whether it is an oblique drawing, so we are not going to see the oblique drawing, we are going to see the isometric, which is also called as axonometric. So this is easy to visualize. Easy to visualize in the sense it has all the three dimensions in a single figure. So you can see an example of a three-dimensional figure here. So we are going to see number of dimensions, number of figures like this. Okay, what is the difficulty is for some, at some places. So here you can see that one difficulty is in isometric views the circle appears as uh, ellipse. Okay, the circle appears as an ellipse. Okay, and here you can see that the angle between this one and this one is actually 90 degrees, but in isometric view it is seen as an obtuse angle, that means greater than 90 degrees. So that is the difficulty, so in using axonometric or isometric view. Okay, and this is very important, so in this topic. Okay, so there are two types of projections. So one is first angle projection and another one is third angle projection. We have detailedly gone through about this particular topic. So when I talked about orthographic projections before starting the projection of points, so actually I told that there are four different quadrants, so and four different projections. Since in second angle projection and fourth angle projection, since the views merge with each other, since the views merge with each other, so I told you that so we cannot use second angle and fourth angle projections. So and we have the remaining two, first angle and third angle projection. So here you can see that the violet color what you are seeing here is the horizontal plane, and the red one the vertical plane, and this blue color one it is the profile plane. Okay, and this is the first quadrant. So as it is written here, shown here, so it is the first quadrant. And coming to the third angle projection, so you already know that if an object is placed in the third quadrant, its position will be below horizontal plane and behind vertical plane. um, there again, so this particular thing is the horizontal plane, this is the profile plane, and this is the vertical plane where its front view will be projected. So here it is mentioned that first angle projection is used in European countries, and it is an ISO standard, and third angle projection is generally used in the countries like Canada, USA, Thailand and Japan. So these are the countries which are using the third angle projection. Okay, and orthographic views, and again if you take, this is a first angle projection, that means an object placed in first quadrant. So this bottom one is the horizontal plane where the top view will be projected, and this red color or little brown, reddish brown color, so this is the vertical plane where the front view will be projected, and this blue one is the plane, profile plane, so where the side view will be projected. Okay, So here you can see that some small man shaped kind of things are shown here. So this is for the front view, and this is for the top view, and this is for the side view, and similarly for third angle projection also it is shown. Why we are discussing about these things in this particular topic is when when an isometric view is given to you, so you are supposed to draw its front view, top view, and side views. If asked a single side view, if it's a left side view or right side view, you can draw any one of those views. And for some cases they may ask you draw the both side views, left side view as well as right side view. So that's why we are discussing this one. The position of these views, where we have to position these views, that means first if I draw a front view, and next if I want to draw the top view, where I have to draw this top view, I mean to the beside of front view, to the bottom of the front view, above the front view. So regarding the position of drawing the position of next view, so we need to know little bit about this first angle and third angle projection. So in this particular uh, slide, so here you can clearly see that in a first angle projection, okay, if I start my figure by drawing the front view, so the top view should be exactly below that of the front view, and to the left side of the front view, whatever we are seeing from the right, whatever we are seeing from the right side, that one should we have to draw it on the left side of the front view. So here left side view is not shown, okay. Whatever we are seeing from the left, that means we are whatever the dimensions that we are able to see from the left side, so that will be there on the right side of the front view. So when we are following the first angle projection, so whatever the isometric views that I will be giving for you, so we will be following the first angle projection, but you need to have the understanding and the difference between the first angle and third angle projection, okay. Coming to third angle projection, so if you observe all these six figures here, apart from these green ones, whatever the six figures that you are seeing here, all these three figures in first angle projection are exactly 100% same as the three figures that are there in the third angle projection. But what is the difference that you are seeing here is the regarding the position of the views, okay. So here the front view is same, here the front view is same, okay. To the left side of the front view in first angle projection, right side view is there, but whereas if you see the right side view, it is there on the right hand side of the front view in third angle projection, okay. And coming to the top view, when you are following first angle projection, top view is below the front view, whereas in the third angle projection, if you are following third angle projection, top view should be always drawn on the top of the front view, okay. So these things you already know, okay, when we have discussed about projection of points. If an object is situated in first quadrant, the front view is always above the top view. If an object is situated in the third quadrant, the top view is always above the front view. So these things we have clearly discussed when we have discussed about the projection of points. So this particular slide shows the symbols that are universally used for first angle projection as well as third angle projections. These particular symbols, these two symbols are for first angle projection, these two symbols are for third angle projections. So these symbols they are asked in many interviews, okay. Maybe since you are electrical background, so they may not ask you regarding engineering drawing, but for a mechanical or civil engineering students, so generally what they do is um, they will ask they will ask um, draw the symbol for first angle projection and draw the symbol for third angle projection, show the difference between first angle and third angle projection. So like that they will ask in interview. That's why I have put up this slide here, and here we will see one example. So here we are going to see one example. So here an isometric view is given, okay. So here we are seeing, if you assume this one as the length, so this may be your breadth, and this entire thing can be your height. So you can see all the three dimensions in a single view. Okay, so if you observe this particular figure, so from this figure what you are supposed to do is you are supposed to draw the front view, top view, and since you are able to see the left side view, so that left side view I already mentioned to you that we are following the first angle projection. If you are following the first angle projection, whatever the thing that you are seeing from the left side, that means from here, that should be drawn on the right hand side of the front view. That should be drawn on the right hand side of the front view. Okay, so one important point regarding the isometric view is, okay, so for every isometric view, so there will be one arrow mark like this. Okay, for every isometric view one arrow mark will be there which indicates the front view is from this end. Okay, if an arrow mark is given like this, so you have to understand that, so you are standing here and you are seeing the front view. Okay, and this is the top view is generally same for all the views, for all the isometric views. And in this particular positioning of the isometric view, so we are able to see only the left hand side view. In any isometric view, so we can see only one side view, either it can be left side view or it can be right side view. But in this isometric view we are able to see the left side view which has to be drawn on the right hand side of the front view. Okay, and this is one very good slide, so which shows the various things what you are able to see in different views. So by means of a color coding they have clearly shown here. The one which is in yellow, so visible from visible from front view. So here arrow marks are given front view, and the pink color is the top view, and this blue some lux green or something, so this one is the side view. Okay, so what out of these all these dimensions that this isometric view has. Okay, um, so what are the things that you are able to see, what are the things that you are able to see, so that is mentioned here by means of color coding here. So the whatever the thing that is mentioned in yellow here, so that is visible from the front view. Okay, in the next slide I am going to show you the solution for this one, so there you can clearly understand so how the front view will appear, how the top view will appear, and how the side view will appear. Okay, so whatever the thing that is there in the yellow, that things can be seen in the front view. Whatever the thing that is there in the blue color, okay, so here blue color is there, and here something, so for this portion blue color is there. Okay, and this also should be made in blue color since it is used for top view. So I think they forgot to mention about the side view. So since it is a slant edge, okay, this one, so it is we are able to see that one in the side view also. And whatever is made in the pink, okay, so this entire thing, so that portion, so we can see from the top. So here also made it is made pink, and this one it is also made yeah, here it is clearly the green one, so it is clearly mentioned that visible from top view and side view. So since two colors are getting merged there, so that's why they have made it different. So they have used green color and they are telling that visible from top view as well as side view. And if you see this violet color kind of thing, so it is this particular portion, so we are able to see this one in the front view as well as in the side view. Okay, so not visible from any views, that means, so you have to understand that this is a hole, so this is a hole, whereas this one is also a hollow portion, this one this white portion, so that one is a hollow portion. Okay, yeah, so um, this is the solution, so which I am talking about. So for this particular isometric view. Okay, so front view will appear like this. So if you see the before slide, and if you see this particular solution, so you can clearly understand why these solutions are like this. So this is the isometric view, and you are supposed to draw these three views like this. So here it is clearly mentioned that front view, side view, and maybe this one should definitely be the top view. Maybe it is mentioned, but it is not able to seen from it is not able to visible. Okay, So this one is the front view, and to the right side of the front view, here it is mentioned side view, but it has to be definitely left side view. Okay, LSV, left side view, and this should be the top view. Okay. There are two more examples which I want to talk in the introduction part. Okay, so here this is an isometric view, so you are not able to see, so here the dimensions are not mentioned, again by means of color coding. So they want to tell us, so what are the different things that will appear in different views. Okay, so here all these three arrow marks are given, but in general for an isometric view only one arrow mark will be there, like I already mentioned, which will indicate that the front view is from this end. Okay, so if you see from here, uh, in front view what will appear for you in this isometric view is, if I say that this is the length and this is the breadth, okay, and this is the height, in general in front view you can able to see the length lines as well as height lines. Okay, so this entire thing that you are able to see here, so that one is drawn here. Okay, and little dark color of this pink, maybe pink, yeah, pink. So this one also we are able to see. Okay, the one and most important thing, one and only most important thing that you have to understand from here is, okay, out of these three dimensions, length, breadth and height, okay, one dimension will become zero in one particular view. Okay, so you have to clearly understand this one. In front view you are able to see length lines as well as height lines, but what about these breadth lines? Here this one, whereas this one, so these lines, they are like perpendicular to you, so perpendicular for your view. That means these all lines, so which are parallel to breadth lines, so they should appear like a dots, they should appear like a points. Okay, now if you see the top view, what are the two lines that you are able to see is, out of these three dimensions that are there, length, breadth and height, what are the two things that you are able to see is length and breadth. Okay, so these are the length lines and these are the breadth lines. Okay, and what about the height? So you cannot say what is the height of any particular three-dimensional object, so from the top view. So okay, here whatever is marked in the green color, okay, so that is drawn here, this particular L shape. Okay, this particular L shape is first drawn here, and after that, so this line becomes zero, again this line becomes zero, since it is perpendicular to the top view. So perpendicular, since it is perpendicular to the top view, this line, whatever the lines, so which are vertical, so whatever the lines which are vertical, so those lines will appear like points. Okay, so these concepts are taken from the projection of points only, so no need to worry about these things. So I hope we will definitely understand this one. And next we are able to see, so this rectangular kind of thing, and after that this line becomes zero and this line becomes zero, and once again we are able to see this one. Okay, so your top view is completed. Next, coming to the side view. So side view, so why it is drawn on the, this side view, why it is drawn on the right hand side of the front view is, since it is left side view. So left side, since we are seeing this particular thing from the left hand side. Okay, so that's why it is drawn on the right hand side of the front view. This one I clearly mentioned some time back. Okay, so when you are seeing this one from the side view, so this particular L shape we can see. Okay, so that particular L shape is drawn here. Okay, and after that, so one more important point here is, inside view what are the two dimensions you are able to see and which dimension is going to be zero. Okay, so zero in the sense it is there, but you cannot see that dimension in the, in that particular view. So now I am talking about the side view. So when you are seeing the side view, so you are able to see height lines and you are able to see the breadth lines. So what about this length line? So this length lines, so will not appear, so in the side view they will appear like points. Okay, so that's why, so this light blue color, so that L shaped one, so it is drawn here, and after that this little dark blue and this little dark blue, so those things are again drawn here, so which completes the all three views, so front view, top view and side view. Okay, and one more example, similar kind of example we will see here. So here you can see an isometric view is given, okay, and this is the front view and top view, and again left hand side view, so which should be drawn on the right hand side of the front view, okay. So when you are seeing from here like this, okay, right, if you start from here, so this all yellow kind of thing, so you are able to see in the front view, okay. So that one is drawn separately here, okay. And coming to the top view, whatever is there in the green color, so that entire thing, so you will be able to see in the top view, as well as so this particular pink color and this particular pink portion, so you will be able to see in the top view. So this is how the top view will appear, okay. And when you are seeing this one from the side, so first you are able to see this particular rectangle, so which is drawn over here. And next thing is, this entire surface is slant, okay. So slant in the sense, you can see this entire portion in the top view as well as in the side view also, okay. And this particular blue color, so it is mentioned here, okay. And side view, yeah. So they have done some mistake, I think, here, okay. Apart from this, so if a question is given to you like this, okay, if this is your isometric view, so these three are the solutions for your particular question, okay. So drawing the front view, top view and side view. So always it is recommended to start your view by drawing the front view, so front view or top view, but in general it is recommended to start by using the top view. So mostly, what are all the different, I mean, things that you are able to see, a more number of dimensions in which view you are able to see. So that things we will draw first. That view we will draw first. Okay. So with this one, after this, so I'll try to give the solutions for some of the problems which I have already sent to you. For your mail, I have already sent 12 questions, 12 questions to you. So out of that 12, I'll try to solve at least some 4 to 5 problems, maybe 4 problems, and that problem videos. So I'll send it to you, and the remaining problems, so you have to solve it by yourself. If you have any doubt, so you can please feel please feel free to contact me to if you have any doubts. Okay, thank you.